Ah, kids. All right, we're going to do convex mirrors and what they do to light. Um, and again, we're going to start with this picture because if you understand this picture, you should always draw the ray diagrams correctly. So this one, remember, convex mirrors makes the light rays bounce up. Why? Because again, it has to follow the law of reflection. But it doesn't randomly bounce up. It bounces up as if it came from the focal point. So see how I'm lining it up with the focal point? And so I am going to draw it like this. Now I'm going to draw it dotted back towards the focal point because again, is the light ray actually traveling back here? No, of course not. It just seems like it is. It seems like it's coming from that point. And then do the same thing for these other ones. So that is solid. This is dotted. And then do the same thing for this one. And then for the last one. All right, and then if you take a look, so it should look something like this. This picture is going to be the key. See how it is spreading the light out over here? That's called diverges. It's diverging the light. And then does everybody see how F right here, the light is not actually going there. It just seems like the light is going there, which means that F is going to be negative, which means it's a virtual focal point. Okay, the light is not really going there. It just seems like it's going there. Everybody got that okay? Okay, so then let's do one of these guys. We need a convex. Hang on, I gotta find it. All right, so let's do a convex. Let's do, I don't know, H. Okay, so everybody find H in your packet. We're gonna work through this one. Okay, so I want to draw my ray diagram. So let's draw it first. So we're going to start with that. So I start parallel. And then it's going to bend up, but it doesn't randomly bend up. It bends up as if it comes from the focal. So draw it as if it's coming from the focal. Okay, so the light is really doing this and then here, but it just seems like it came from back over here. Okay, and then we want to do that one in reverse. So I'm going to go towards the focal. Does everybody see how I'm going object towards the far focal point? Okay, so I'm going towards that focal, and then when it hits the mirror, it comes out parallel to the principal axis. But hopefully that makes sense why when I say if you understand this picture, okay, you should be able to draw the ray diagrams because two of the rays is that picture, you know, this one and then this one. Those are the two pictures. And then your third ray that I want you to draw is going to be this one, the center ray. So if we want to draw that one, and then I'll draw the fourth one too, just so you have all four. But you see how I'm lining it up? And this one is the one that would go straight there and then straight back, because it would be hitting at an angle of 0 degrees from the normal. So it would go like this, and then it would go straight back. Okay. And then really the last ray would be the one that hits right in the center. So I'll draw that one. And then it has to follow the law of reflection. So this is 1, 2, 3, 4. 1, 2, 3, 4. So it would go 1, 2, 3, 4. So it would go through that point. And it would look something like that. All right. So now you might go, wait a second. I have this light ray. I have this light ray. I have this light. Nope, this light ray. And this light ray. They're never going to meet. That's okay. Okay. Because it's a virtual image, so you have to extend the light rays back. So if I extend this first one that I bounced back, hey, look, there's hopefully where my image is going to be. So hopefully my image is going to be right there. It's going to be a virtual image. Okay, smaller right side up. The light rays are not actually going there. But let's just check it. Let's extend the other ones back. So if I extend this one back, okay, I didn't do perfect with that one because it's missed by a smidge. If I extend the center one back, the one that hits the center curvature back, that one did a better job. Okay, they all meet right there. All right, so drawing it, that makes sense. So this would be a virtual image. It would be right side up. It would be smaller. And then if I have to do my mirror equation here. So let's do the mirror equation. 1 over SO plus 1 over SI equals 1 over F. SO is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 over 9 plus 1 over SI equals 1 over F. Now, if you just go 1, 2, 3, 4, 5, 6, okay, if I was just to plug in this and then plug this into my calculator, I want to show you something, and I'm purposely doing it incorrect. Hopefully you know why, what I'm messing up here. Okay, I would get 18, and it'd be positive 18, and you would go, well, wait a second, that doesn't make sense. Positive means it's a real image. That's not a real image. That's a virtual image. And 18 centimeters, that is not 18, or 18 little boxes. That's not 18 little boxes away. So what did I do? Oh, remember, this is a virtual image. So that this has to be -6. Okay? So use your brain. Don't just go, oh, well, my calculator says this is my answer. No, think about it. So let's try this again. Now when I do it, I get SI to equal -3.6, whatever those boxes are, units. And if you look, 1, 2, 3, hey, I would buy that's 3.6 units away. And then if I want to do the magnification, SI over SO equals HI over HO. So if I want to do my magnification, I would get 3.6 divided by 9. Again, negative, but it's going to be absolute value. So that means my magnification is 0.4. So if I was to want to find my new height, okay, if I take 4 times 0.4, I get 1.6. So HI is 1.6 units. And let's see, I would buy that's about 1.6. Okay? All right. Hopefully that makes sense, and then you should be able to do everything else. But the nice thing about convex mirror ray diagrams, every single time you always get the same thing. So if you know how to draw one, you can draw them all. All right. Bye, kids.